It's 9 o'clock. It's time for halogen reactions. So, in the last lesson, you learned about halogens, you learned about their properties, and you learned about yeah, that's their properties. Okay. And why they are the way they are, why they are so reactive. And so today we're talking about some of those reactions that they have. So we know they're reactive. Let's look at some of the reactions. But the start is, what are the names of the halogens? Easy. Can you put them in order of reactivity? Let's start with the most reactive and then go down to the least. Which halogens could replace the halogen in NaCl? Ooh, that's tricky. In fact, that's today's lesson. Fun that. What features do all halogens share? What is the charge of a halogen when it becomes an ion? Tricky. And what is the name of what names? How do the names of the halogens change when they become ions or when they bond? A little video for you to watch later, just for fun. Okay, pause and do the questions. I'm going to pause as well. I forgot my pen. Pause. Okay, have you done it? I have my pen. Right, let's put the pen on the pen thing. Pen. Red. Splendid. What are the names of the halogens? We have fluorine, chlorine, iodine, and bromine. You could also add acetylene. That's the worst F. You could also add acetylene, but that's radioactive, so we won't really bother. Put them in order of reactivity. I have already done that. Check it out. Fluorine, chlorine, iodine, bromine, going... Oh, no. Hang on. That's the order. Fluorine, chlorine, bromine, iodine. There we go. Fluorine is the most reactive. Chlorine is the next most reactive. Then bromine, then iodine. Which halogen could replace the halogen in NaCl? Look at this. Which is the halogen in NaCl? Sodium chloride. Chlorine. The only one that could replace it is fluorine, and we'll look at that today. What features do they all share? They are poisson. What is the charge of a halogen when it becomes an ion? It becomes an ion. It has, remember how many electrons it has in its outer shell? It has 7 electrons in its outer shell. How many does it want? It wants to have 8. If you add an extra electron to make that 8, it becomes negative, so it has a -1 charge. And what is the name of the halogens? What is wrong with this question? How do the names of the halogens change when they become ions or they bond? They become, well, like this one. This is sodium chloride, but the halogen by itself is chlorine. So how do they change? They become an ide, as in chloride. When they bond, they turn into an ide. Hey ho. So let's go on to the next page. True or false? Easy. 1 to 9. Write those numbers 1 to 9 in your book, and then do the questions. I'll read them for you because I'm kind like that. True or false about the halogens? They are monatomic. They are diatomic molecules. They can't be both. So which is it? The molecules are held by strong covalent bonds. They are ionically bonded. There are weak intermolecular forces. They have low melting and boiling points. They have high melting and boiling points. They are poor conductors of heat and electricity. The melting point and boiling point increase as you go down the group. Okay, pause. Give me the answers. I'll just wait. Okay. Excellent. True or false? They are monatomic. That is not correct because they are diatomic. True. The molecules are held by strong covalent bonds. They are held together by strong covalent bonds. We'll look at those in a moment. They are ionic bonded. No, because we just said they're covalently bonded. There are weak intramolecular forces. That's like really poorly phrased, but that's true. Although those covalent bonds are really strong, so like covalent So chlorine and chlorine, so Cl2, because they're diatomic, held together. That bond between the chlorine and the chlorine is really strong. There is almost no forces between chlorine and another chlorine. So you got like Cl2, Cl, and another Cl2, Cl. So that's Cl2, Cl2. The force here, this covalent force, is hella strong. That's really hard to break up. But between these two molecules, ain't nothing. That's a really weak force. Okay? They have low melting and boiling points. Fluorine's a gas, chlorine's a gas. Yeah, it does change as they go up. No, as they go down the group, because fluorine's a gas, chlorine's a gas, but bromine is a liquid and iodine is a solid. So it does get higher, but they're still relatively low. They have high melting and bonding points. No, they are poor conductors. Tick. They're non-metals. Almost all non-metals are poor conductors. The melting point and boiling point increase as you go down the group. I just said that because as you go down, they start off as a gas, and then they are liquid, and then they're a solid. That means the boiling point has to increase. So tick. True. How did you get? Did you get 9? If you did, well done. If you didn't, it's okay. But learn from your mistakes. What are halides? When halogens react with another substance, they become negative ions, as they are gaining an extra electron. When this happens, they are called halides. And I did that in the start. What do they change into? Fluorine, when it reacts, becomes fluoride. Chlorine, when it reacts, becomes chloride. Bromine, when it reacts, bromide. And iodine, when it reacts, it's a weird sounding one, iodide. Iodide. I'm fine now. Iodide, bromide, chloride, and fluoride. Those are the names of the halogens once they have bonded, once they become an ion, once they've gained an electron. So in their pure state, fluorine, chlorine, bromine, iodine. In their ionically charged state or bonded state, fluoride, chloride, bromide, and iodide. Maybe that's something to write down. Maybe not. See you? Okay, we're just reviewing things. All have 7 electrons in their outer shell. You knew that. How did you know that? Apart from the fact that I've just told you it, and I told you it in the lesson before. What is the clue that allows you to know that? Maybe it's the periodic table? Yes, you're right. It is the periodic table. It's because they're in group 7. And if they're in group 7, that means they have 7 in their outer shell. How can they become ionically? Sorry. They all want to gain one electron. They've got 7. Okay, let's just go back. What do they want? Full outer shell. How do they get it? They either lose 7 electrons, so there's a full outer shell, or they gain 1. It's much simpler to gain 1 electron. How can you gain 1? You gain 1 from stealing from somewhere else, and you can become ionically bonded. So you accept an electron from a metal to become a halide ion. So, for example, sodium chloride. Sodium has 1 in the outer shell. Chlorine needs 1 in its outer shell, and they come together. Giving one throws the electron away, the other one takes it, ionically bonded, and forming a lovely lattice. Covalent is when 2 elements are in the same situation. You need an electron, I need an electron. Let's work together. I'll give you one of mine, you give me one of yours, and together we form something beautiful. More questions. Go on, just do it. 1 to 4. How many electrons do they have in their outer shell? Did you listen? I'm not even going to give you the answer. You didn't listen. What do they need to do to become stable? What types of bonding can they do? What type of compound do they usually form? I'll give you the answers another day. Excuse me. Okay, so here we go. Here is an example of some ionic bonding. So here we have sodium. Sodium is in group 1. Group 1 means it has 1 electron in the outer shell. It loses an electron, so it becomes positively charged, and it's symbolized by that little plus there. Chlorine is in group 7. It accepts the 1 electron. It becomes negatively charged. What do we know about opposite charges? They attract, thank you. They attract together and therefore they are bonded. They are ionically bonded. You know it's an ionic bond. How do you know it's an ionic bond? One, I've told you. Two, it's opposite charges. But the easy one, just to look at straight away, is it a metal and a non-metal? Sodium, metal. Chlorine, non-metal. Therefore, has to be an ionic bond. Okay? Here's another example. Calcium, metal. Fluorine, non-metal. Calcium's different. It's not in group 1, it's in group 2. What does group 2 mean? Yes, it has 2 electrons in its outer shell. 2 electrons. So when it loses those 2 electrons, it becomes charged, positively charged +2, which means calcium needs 2 fluorines to balance its charge, because each fluorine has a charge of -1, the old dog. So it needs 2 fluorines to balance its +2. So +2 here, -1, -1, and the whole thing levels out nice and simply. Covalent bond, as we said, is the sharing. Here, hydrogen has 1 electron in its outer shell. It needs 2 because it's only on the inner shell, so it's small. And it's like, I need an electron. Chlorine has 7 in its outer shell, and it says, I need an electron. And they come to an agreement. And hydrogen says, you can have my 1 lonely electron. And chlorine says, you can have 1 of mine. And they place them together, and it's sharing. Because now hydrogen has 2 electrons in its outer shell, and chlorine has 1, 2, 3, 4, 5, 6, 7, 8. Nice. To work out how many they need is how many they give. So chlorine needs 1, it gives 1. Hydrogen needs 1, so it gives 1 over. And when they do that, their outer shell become full, and they become covalently bonded. How do we also know it's a covalent bond? Because hydrogen, chlorine, both non-metals. Non-metals must be covalent. Chlorine, Cl2, chlorine and chlorine, non-metal, non-metal, sick. We mentioned this the other day. This is just an important reminder. Reactivity decreases as you go down the group, or reactivity increases as you go up the group. Why is that? It's because, I think so. Yes, hold on. It's because they want to take in an electron. How do you take in an electron? You draw it in with your positively charged nucleus. Which one's more attractive? Well, let's look at this fluorine. This fluorine is smaller, so that positively charged nucleus can reach its positivity out further and more likely to pull that electron in. Chlorine is bigger, so that positivity spreads out, so it's less effective. The strength is not so much so strong. The strength is not so strong. I'm sorry about that. I'll think of a better phrase later. But yeah, so that's positivity as it's spread out has weakened, so therefore it is less attractive. Bromine is so big, the attractiveness of bromine has just gone right down because that positivity is spread out even further, so it is less attractive. So as you get bigger with the group 7, they become less attractive. The opposite of the alkali metals. Oh, look, attractive. Oh, look at that. See, the bromine attracted an electron, but it was much slower than the fluorine. Should I do that again? Woo! PowerPoint animation. Boom. Okay, so we're going to look at, the whole point of this is displacement reactions. So we start off with a metal and a non-metal. What type of bond is this? Yes, ionic. Well done, thank you. Mr. Sodium and Miss Iodide. What a lovely couple. Mr. Sodium, quite a reactive metal. Miss Iodine, not so reactive. But along comes Miss Bromine. Check her out. She's higher in the periodic table, so therefore she is more reactive than Miss Iodine. And Mr. Sodium, he just loves the reactive element. He doesn't love Miss Iodide for what she is. He loves her for what she can do. And Miss Bromine, she can do more. So what happens is Mr. Sodium dumps Miss Iodine and heads off with Miss Bromine. She becomes Miss Bromide. Miss Iodine goes back. Miss Iodide goes back to Miss Iodine. So a displacement reaction is when you have a compound. There we have a nice compound here of something and a halogen. Normally something like a group 1 and a halogen. Sodium iodide compound. If you throw another halogen into the mix, and that halogen is more reactive than the one already bonded, that halogen will steal what it was bonded to. It steals the sodium away from the iodine, leaving the iodine just on the side, in tears, sad and alone. So 2NaI, sodium iodide, bromine comes along, Br2, bromine steals the sodium to becomes 2NaBr, leaving the iodine all by itself. Here we have another one. Now bromine has its comeuppance, because potassium bromide plus chlorine, which is more reactive, chlorine or bromine? Chlorine, obviously. So we end up with potassium chloride and bromine is left on the side. So as long as another one, more reactive, comes in, the less reactive one gets kicked out. What would happen if you put fluorine into the mix? The chlorine would get kicked out, because chlorine's more reactive than chlorine. There we go, done that same thing. So here's what it would look like. Sodium chloride. Oh, here we go. Fluorine. Look at this fluorine, much more attractive than this one. Look at this. This positive, this is attracted to negative. Here we go. Oh, this one is more reactive. Chlorine turns into chloride. Fluorine turns into fluoride. Steals its girlfriend or boyfriend, depending on how you want to look at it. So if you put a more reactive halogen in with a compound of another halogen, the more reactive will steal from the other one. It's called a displacement reaction. And here's that last one in terms of equation. Fluorine plus sodium chloride turns to sodium fluoride plus chlorine. I've done a lot of talking in this video, haven't I? Really sorry. Remember, notice the fluorine, because it's by itself, turns to fluoride because it's become a compound. The chloride, because it's a compound, goes to chlorine because it's not a compound. Maybe write that down. This is called displacement reaction. Done? Splendid. Oh, should have said that first. Okay, another thing. Copy this down. Go. I'll pause. Okay, so now what I'd like you to do is predict what's going to happen when you mix these two things together. So here we have, is this the right one? Yep. If you have potassium bromide plus, in this box, potassium bromide plus chlorine, what will you end up with? What happens? So potassium chloride, so I can write on here, potassium chloride plus potassium bromide. Oh, that's awful. What does it turn into? If you want to do it as symbols, that's fine. Simple. What happens? Do the same here. What happens when you mix potassium iodide and chlorine? What happens when you mix potassium iodide and bromine? These ones are crossed out because you'll notice that bromine with bromine, they're the same halogen. There's no point. What happens here? Bromine, potassium chloride. What happens? Fill it in. Pause. Do it. Okay. Hopefully you've done that. I'm going to move on. Here's a little animation of what it would look like. The truth be told, if you were to do this, don't do this at home. So I've got 2 KBr. What's KBr? Potassium bromide. Next. If you add the halogen, if there's a reaction, you see a colour change. That's a sign of chemical reaction. If if there's no reaction, you don't really see a chemical change. If there's no chemical reaction, you don't really see a colour change. There we go. So Like so. We know the colour of bromine is displaced, so there we go. Bromine is brown colour, so we see it displaced. So you should have done that. Here are the answers. It turns to potassium bromide, and chlorine turns to potassium chloride and bromine. Potassium iodide and chlorine turns to potassium chloride and iodine. Bromine, potassium chloride, no reaction because bromine is less reactive than chlorine. If we go, bromine is more reactive than iodine, so we get potassium bromide plus iodine. Iodine gets kicked out all the time. And if you put iodine in with the other ones, it doesn't do anything, it's too weak. Sorry, iodine, you need to do work on your guns. And here we go, we have reached the end. I'm sure you're relieved. There's a lot of me talking. Here are 8 questions. Don't write the questions down, just write the answers. What property of the halogen suggests they are non-metals? What test could you do on an iodine crystal to confirm that iodine is a non-metal? Molecules of the halogens have 2 atoms, FF, Cl, Cl, Br, Br, II. The bonds between the atoms in the molecules are strong. How can you account for the fact that halogens easily become gases? Did that in the starter, I think. You're not sure within the one. What kind of compound is formed when a metal reacts with a halogen? It's a general term. What are the formula of the compounds of halogens with group 1 metals? What is the pattern? Do a group 1 and a halogen. Do another group 1 and a halogen. Are they all the same? As in, do they all look the same? Is it, do you need 2 of one and 1 of one, or are the ratios the same? That's what I'm looking at. Are the ratios? Identify 5 ways in which chlorine, bromine, and iodine are similar. 5, tricky. What is a trend down the group in boiling points of the halogens? How does it change? What is the trend in the reactivity of the halogens down the group? And identify 2 reactions which illustrate the trend. That's very relevant to today's lesson. Okay, I hope that made sense. If you have any questions, email me, leave a comment, or just, try. Okay, love you, bye.